runs, wickets, batsmen, overs, and the stuff. But still, we have to write it with hand, or else we have to hang placards. So we propose a solution to this. So this is a person. The person holding the cell phone is a person who is going to send, send signals to the scoreboard, and the same signals. Suppose I'm not able to see the match on live. So I can even if I'm sitting in my lab working on a research project, I can still see the live scores, if I access the university website. So apart from this digitally visible scoreboard, we have sent the data to the university server as well. But the limitation is that since it's a university server, we are working on intranet or not internet exactly, because you have to log into your own ID and then get into this. So we are still working on this. How can we make it accessible to a wide range? So you can see here, wheels attached here also, here also. Here it is understandable that wheels will be here, so it is mobile. It can be transported anywhere in the field. But why wheels here? Means it is detachable. Okay, so this is a tall board. It's 10 feet tall. So if you want to use it for indoor sports, you can detach it from the lower stand and the upper stand and carry and push this one forward and use it for indoor games like badminton, lawn tennis. So the proposed design is, what will be here? Since it's a multi-sports scoreboard, that means it has to display all kinds of sports, at least major sports that are played in the university. So this is KMH, Kanchanjunga Men's Hostel versus Untitled Men's Hostel. Score over wicket, score set over wicket. This side will be the batting side, this side will be the bowling side. And sets for other games like badminton, lawn tennis, okay, and other games where we need it. And then, so this is the IOT integrated solar tracker, the charge controller, and the battery. So we are using a lead acid battery. Features of the scoreboard: portable. It's portable and height adjustable. Multi-sport display. Both indoor and outdoor games can be displayed here. Web support. Display the scores on the website directly from the app. App control upload scores wirelessly from your phone. You don't have to stand near the board in your right hand. You can always update the scores at a distance. IoT-based smart solar tracker. Okay, the solar power, the solar panel, the solar power that we are going to generate, it is also going to be a solar tracker. Means we will design an actuator that will rotate the panel in the direction of the light. Okay, because the whole day the light will not fall on the solar panel at a particular angle, right? So it has to rotate according to the direction of the sun, the light. So it will sense. We are going to use a sensor that will measure light intensity and then rotate the panel accordingly. Okay. Next is hybrid power. So we have connected both solar panel as well as AC and DC batteries, and AC plug-in is also possible. Sensor. So LDR is this one, light dependent resistor sensor that will sense the light intensity. Actuator will be a servo motor that will rotate the solar panel of the board. Networks wireless data transmission from the mobile app to the board. Sensor data to the Arduino processing. And its user interface, controllable. It's very simplified, nice, user-friendly app that we have designed. The smart control integrated with IoT. So this is the first primary home page that we have designed. We have designed this app right from scratch. So as you can see, connection is Bluetooth. So from the cell phone, it will connect to the board to Bluetooth module HC05. And then we are going to upload the scores and stuff. And then there is also a timer. For example, time-based scores, sports. For example, football, 90 minutes. We have to finish it within 90 minutes, so you need a timer as well. So we also have an online, ongoing simultaneous timer for that. And there's a light tab, and it don't occupy much space in the cell phone. It is compatible with Android smartphones as present. User friendly with a login page. Okay. So anyone with a anyone with the app. Well, it might happen that I have installed the app, then I distribute it to all the members of my hostel, and then I will say whenever the opposite hostel plays, just keep on manipulating the scores, right? So it is another HEPA. So we have also introduced for security purpose a user ID and password that will be limited to the convener of the game. This is the circuit design layout. So if you see from the smartphone, it is connected to Bluetooth to the main master microcontroller. This microcontroller is transmitting the wireless signal NRF to NRF through NRF to the sub master microcontroller and sub master microcontroller 2. There are two sub master microcontrollers. The first sub master microcontroller is connected to 1, 2, 3, 4, 5. 5 displays. So dot matrix displays, DMD. So these are over one, set, over to wicket to timer. The second, excuse me, the second one is connected to T1, T2, score 1, score 2. So that means there are 9 displays, 9 numbers of DMDs. So this is the back panel circuitry that we have designed. So just like in the previous slide, there was a master microcontroller. So this is the master microcontroller in hardware. The previous design wasn't, we have just designed a layout. This one is a hardware one. So sub master microcontroller 1, sub master microcontroller 2, and a state microcontrollers connected to all these dot matrix display here. So these are the electrical components that we have used in the previous circuit design. The next is, this is the upper frame of the scoreboard. This is where we are going to place the scores. This is the lower part of the scoreboard frame that we have designed. So this is welding going on in our mechanical workshop, mechanical engineering department. We are working there. We have taken their help. So this is the lower part. So as you can see, this is detachable. This with the wheels attached here, and then will be connected to here. So this is also detachable. This is also a standalone system, and it can also be attached to here. And this is a solar panel tracker that I was talking about. Okay, so power will be generated from here and operate this. So initially we began with the design where we are going to place the displays. So this is the plyboard that we use, and this is the front plyboard and the displays we have designed. You have already seen the back panel circuitry in the previous slide. This one is the front panel one. So this is the integration of the battery and the solar panel. And this is the back portion. So this is the front portion, and this is the back portion of the circuitry. And this is my team that we are working together in our lab, in the control system lab of Department of Electrical Engineering. So integration of solar power, upper frame of the scoreboard, lower frame of the scoreboard, and the front panel design. So this is when testing and validation was done for the scoreboard. We were visited by Professor Dhanapati Deka. He's the Dean of Student Welfare at Tezpur University. So he visited us for the testing and validation of the working model. This is Professor Deka. So from unspark, we went to spark model. This is it. And this was a project design and development of a green power smart multi-sport scoreboard. The project grant was 2 lakhs. We got this project from the university itself under the research and innovation grant. And okay, these are my details in case you would like to know something about the project, anything more. And I would love to show you a video. It's only 59 seconds. It won't take much of your time. So connection, Bluetooth is connected. PNH means Pakka Net Hostel. PNH is Team 2 score. How much does it score? Team 2, let's see. 099. 099 display. Sets over his house. Maybe 6 over is going on. 6. And the wickets, follow wickets is 9. And the timer, 55. 55 minutes. And it will count backwards, 55 minutes to 0. We also, Department of Electrical Engineering, we also have designed IoT-based ventilators, which was highly publicized and nationally recognized. But since many people have already heard about it or known about it, I haven't mentioned it here. But all of you are welcome to our department, to our university, to see all these working models, especially the IoT-based ventilator, which was very much in demand. Many government sectors and agencies had also come here to our university to demand the rights for it. We have applied for patent for it, our department. And these are one of the working models, as I said. So welcome to our university. Please come here, and we will invite you and invite us also, so that we also always maintain nice, cordial relation. And thank you. Thank you for having us here. Any sports enthusiast?
Can I, ma'am?
Hello.
Can I ask, ma'am, how much did it cost for making that board? Just roughly how much?
Are you talking about the frame? The frame, it cost a bit, but the circuitry didn't cost much. It was within 20,000. Actually, we were paid 2 lakhs, but the 2 lakhs was for the research, the total research. Okay? So 2 lakhs we didn't spend on this totally.
Means they have tested on different
Yes, we have tested on different circuits. And Dr. Sonal also helped us with his knowledge because he's an expert in this. And when we began this, it was before COVID. So 3 batches passed away. We did, first batch we came, went away. The second batch, oh, it's lockdown, how will it work, it went away. Now in third batch we are nearing completion. So initially we made 7-segment display, which was larger than this DMDs. It was this big. But it was a lot of power was consumed there, and the soldering was, we had to do it manually in the lab. So sometimes one of the soldering was not done properly by the engineering students and the BTech students. So it didn't need to work. So in all those also a lot of money went. Thank you.
Thank you.
Thank you so much, ma'am, for a very interesting presentation, ma'am. So we will head for the next presentation. But before that, I would like to invite the Director of the Member Secretary on the stage, sir. I would like to felicitate our next speaker, Professor Ningrinda Marchand, Department of CAC, Nevis, New Zealand. Arunachal Pradesh, ma'am. So I request Director sir to present her traditional Monpa scarf. So now I invite you, Professor Lingrinla Marshall, and the topic of our presentation is mobile crowd sensing, crowd-based IoT.
So I'm very glad to be here today. I'm Professor Lingrinla Marshall. I'm working in the Department of Computer Science and Engineering. I think the volume is fine, right? So, first of all, I would like to thank the people involved here for inviting me, especially Director, APSCS&T, right? Shri Siddhi Munia, and Joint Director, Shri Bamagapo, and also Curator of this Science Center, Mr. Vivek Kumar. Thank you very much for inviting me. It's a privilege for me to come over here. We are there usually, but Itanagiri is very far away for us because of the road condition and all that. But very glad to be here, and I want to share something about, of course, it's in my research area, but it's something which everybody can understand. Anybody on the street can understand what I'm going to speak today. I'm not going to go too much into the research details, but I'm just going to give you this concept, which it's becoming very popular and which anybody can understand because we all are familiar with our mobile devices and we cannot survive without our mobile devices. And we can really understand this because of this reason. Now, I am trying to make it as simple as possible. So what is mobile crowd sensing? As I have given in the title, in the beginning it's crowd-based IoT. So regarding IoT, we have heard lectures, beautiful lectures regarding IoT, the different things that we can do using IoT. We have seen that, and this is another branch of IoT, which is mobile crowd sensing. The name itself tells you what it means. Mobile means use mobile devices, which everybody has. In this room, everybody has a mobile, and sometimes even some students, one of my students, he was carrying 2 mobiles in the class also. Right, so we have 2 mobiles, 3 mobiles, everybody has 1 mobile. Okay, so we just use mobile devices, and crowd is carried around by a crowd. Like all of us are here, we are a crowd, and they are used for sensing. That's all. Mobile crowd sensing is use mobile devices carried around by a crowd for sensing. So if you go to the definition, this is a formal definition given by some researcher. Mobile crowd sensing is the category of applications where individuals, that is you and I, with sensing and the computing devices, collectively share data and extract information to measure and map phenomenon of common interest. So, let's forget about this because this is just a formal definition that's given. Now, but it means the same thing. Individuals carrying sensing and computing devices. We have our mobile devices, which has got computing capabilities and also the sensors. Most of us may not know this. I also didn't know 5 years back or 6 years back. I didn't know that my mobile had a lot of sensors, which I don't know. I never used also. For example, everybody has a camera in its mobile. That is also a sensor. And we have we also have this microphone, which is a microphone, which is also, we can say, a sensor, and so on. So all these things, this is for the noise, this is for, you can sense the noise around you, and so on and so forth. We're coming back to more sensors that I'll show you here. Okay, so very simply speaking, MCS exploits the power of the crowd. By now, you must be able to understand. You must be understanding by now what is the meaning of exploiting the power of the crowd. So, a person says that the aggregation of data or information from a group of people results in better decisions than those made by a single person from the group. This is true. This is sure. That's the reason why in our villages and in our towns and cities we have meetings. We have groups of people coming together and deciding on something. That's it. So we exploit the power of the crowd everywhere, any place, many places. So here also, in sensing, in IoT, we say that MCS is an IoT